Creating an empty table is only useful if we're able to modify it. And in fact, any table can be modified by inserting, deleting, or changing the rows. Here from the SQLite documentation, you see that there are many different variants of how you might insert rows into a table. We're only going to focus on certain paths, such as writing insert into the table name, specifying the column names, or you can skip specifying the column names. And then you either write down a select statement that adds all of the rows in that select statement to the table, or you specify values directly by including those values in comma-separated lists. Each set of parentheses will create one new row, and what you separate by the commas are the values for the columns in that row. For a table that has two columns, if you want to insert into just one of the columns, then you write insert into T. You say which column you want to insert into, then the keyword values, and then in parentheses you'd put only the one value for that one column. A whole row will be inserted, and default values will be used for the other column. If you want to insert into both columns, then you can say insert into T. You don't specify which column, so that means all of them, and then you give the values that you're inserting into each of the columns. Both of these insert into statements would insert one row. If you want to insert more rows, then you just follow these parentheses by comma and more parenthetical row descriptions. Let's take a look at a demonstration. I'll start up SQLite and create a table that keeps track of positive integers and whether or not they are prime. Let's call it primes. And now I'll specify that there are two columns, n and whether or not it's prime. Now I didn't apply any column constraints there, but I could have. One way to change what I've done is to just drop the table and start over. Now that table is gone, I cannot select star from primes because primes doesn't exist. But if I create it again, then it will exist. So let's make sure that each of these is unique and that prime has a default value. Now there are no Boolean values in SQLite, so you can't have true and false, but it's conventional to use 1 for true and 0 for false. And let's assume things are prime unless proven otherwise. So by default, we'll have prime be 1, meaning yes, I think this number is prime. Now I can select star from primes. I see no contents, but I don't see an error because the table does exist. Now I can insert into primes the following values. 2 is prime, and 3 is prime. And now if I look at what's in primes, I see 2 and 3. Both of them are prime, so that's why we have 1s in the prime column. Now prime is default 1. That means if I insert into just the primes n column, then I'll get the default value for the other column. So if I insert the values 4, 5, 6, and 7, now I have 2, 3, 4, 5, 6, and 7 in my table. This claims they're all prime. That's not quite true. 4 and 6 are not. We're going to clean that up later. What's a quick way to get even more integers into my table? Well, I could insert into primes n the result of selecting all the values in primes. So let's put n plus 6 from primes into my table. And now I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now that primes is different, if I insert again, I'll have an even different effect. So here's what we get when we add 12 to each result that's in there now, and add all those rows as well. It's also possible to update the contents of existing rows. You write update, a table name, set, which column names you're going to change, followed by an equal sign, and the expression that computes the new value for what you're going to put in that column. Now you may not want to update all rows in a table, but only a subset, and so you can include a where clause in order to say which rows you want to change. Let's use update to fix the prime column in the table we've already constructed. So far, we have a primes table with an n column and a prime column. We'd like these to be 0 for all composite numbers such as 4 and 6. Aside from 2 itself, all the multiples of 2 are not prime. So I could update. We're updating the primes table. We're setting prime, that's a column name, to 0. That's a value to place in the prime column. Now I need to say which rows I want to make this change for. I want to make it for all the rows for n greater than 2, where 2 evenly divides n. Now if I run the same select statement, I see that the multiples of 2 aren't prime anymore. If I apply the same logic for multiples of 3 and multiples of 5, then I have correctly marked for the values between 2 and 25, which ones are prime and which ones are not. So sometimes it's easier to build a table not just all in one go, but by manipulating the values after constructing it initially. And that's what we've done here in order to list out some numbers and whether or not they're prime. Finally, it's possible to delete rows. You say delete from, and then what table to delete from. You don't have to delete all rows. Instead, you can provide a where expression in order to delete just some of the rows. But without a where expression, you will delete all of the rows in the table. The table will still exist, so this is not equivalent to drop table. But that table will have no rows, only empty columns, after you delete from it. So for example, I could delete from primes where prime equals 0, and then if I select star from primes, I see only the prime numbers remaining.